Okay, pre-calc, here we go. Our next video about law of sines and cosines. This is going to be actually over cases 3 and 4. So case 3 is when we have two sides with an included angle, and case 4 is when we have just all three sides, and we're going to use exclusively law of cosines for these two cases. Okay, just a reminder about law of cosines. There's three formulas. Don't forget you're going to use just based on what is given, and then it will have two chances. And the nice thing is there is no ambiguous case here to worry about. So if you're given a problem, you're definitely going to have one and only one triangle. If you don't have the formulas down in front of you because they're in your other notes, hopefully, I would definitely copy them down right now. So we've got three formulas. A reminder. The side and angle, so the side that you start with on the left side of the equal sign is the opposite side from the angle on the right side. So side B and beta go together, side A and alpha go together, and then you'll notice the other two sides are represented in the figure. So we only need one angle or all three sides to use this case. Okay, given a scenario like this, you see we have two sides and an angle. So what you have to start off doing is finding your third side. Which means, since we're looking for A, we have to plug in to A squared equals B squared plus C squared minus 2BC times the cosine of alpha. And we tend to do okay as long as we pay attention and recognize our order of operations. So we don't know A squared, we're going to leave that in. B squared we can say is 20 squared plus 30 squared minus 2 times 20 times 30 times the cosine of 60 degrees. Now on this one it's nice because our variable's on our left side, so we can actually all in one foul swoop simplify this, and we would get 700. And so A squared is equal to 700, and then square rooting A is going to be equal to 26.5. So we then know 26.5 for that missing side. And now there's always the question, can we do law of sines from here? And most of the times we can. The problem is sometimes, depending on what side and angle we're using, we can create the ambiguous case again. So it's always best that when you start with law of cosines, if you're given a law of cosines triangle, to keep using law of cosines. Okay, and it can be a little bit more complicated, it can be a little bit more work, but you're never ever going to run into the ambiguous case if we do that. So whatever we do now, we have to find our other two angles. It doesn't matter if we find beta or gamma. Hey, I'm just going to find beta next, which means I'm going to be using B squared equals A squared. I'm using the other formula now, 2AC times the cosine of beta. And so I'm going to plug in the things I know. So I know B squared, I know B, I know A, I know C, and finish off what I don't know is beta. So I'm going to leave that as cosine of beta. Okay, now I'm going to just start simplifying things that I can. So I'm going to do my exponents, 400, and then if I do 26.5 squared, I should get 702.25 plus 30 squared is 900 minus. I can multiply all of that together at once, and that's going to give me 1,590, and then I still have cosine of beta. Okay, now here's where we tend to make a common mistake. We do 702.25 plus 900 and then minus 1590. But since these two are multiplied, you cannot, this is like a variable. We can't combine constants and a variable. We can combine those two. So if I do that, I have 400 equals 1,602.25, and I still have that minus 1590 cosine beta. Okay, the last thing, or second to last thing we're going to do is get rid of that 1590. So for now, we're going to subtract 1602.5 from 2.25 from both sides. And that's going to give me a negative number over here. That's okay. I'm going to have negative 1,212.25, and that's going to equal negative 1,590 cosine beta. Now I can get rid of this number by dividing both sides by that. So cosine beta is going to be equal to about 0.76, and here I have to do arc cosine or inverse cosine. That's going to give me a beta value of 40.5 degrees. So the last thing we're missing then is our gamma. Well, the nice thing with that is we don't have to go through that whole big ugly process again. If we just do 180 minus 60 minus 40.5, we end up with 79.5 degrees. Okay, so that's how we do it for case 3 if it was side angle side. If it's case 4 like this, where you've got all 3 sides, we have to essentially do that second thing we did in the previous slide again. So we're going to need to find alpha and beta doing that, which means we need to start with a squared equals b squared minus c squared, b squared plus c squared minus 2 times b times c times the cosine of alpha. Okay, if I plug that in, I can simplify these two. So I'll have 36 equals, this is going to give us 97 minus, if I simplify those, 2 times 9 times 4, that's 72 cosine of alpha. Okay, I'm going to subtract 97 from both sides. It's going to give me negative 61 equals negative 72 times the cosine of alpha. Divide by negative 72, I get 0.85 equals the cosine of alpha. And then if I do a cosine inverse, I get 31.8 degrees for alpha. Okay, so we know 31.8 degrees. Next, I'm going to find beta. So now I need to have the side with b on the left. So I'm going to have 9 squared equals a squared plus b squared minus 2 times a times b, 2 times a times c, and then cosine of beta. Following the same process, we're going to get 81. I can evaluate or simplify those two, which would give me 52. And 2 times 6 times 4 is going to give me 48 cosine of beta. Subtract 52 from both sides. That's going to give us 29 equals negative 48 cosine of beta. And then dividing by negative 48, I'll have that cosine of beta is equal to about negative 0.60. And our cosine and inverse cosine is going to give us that beta is 126.9 degrees. And then same idea, the 3 angles of a triangle add up to 180, so we'd end up with 21.3 degrees if we took 180 minus 31.8 and 126.9. Okay, so that was case 4. So we looked at both case 3 and case 4. If we give you a challenge problem here, so this will be, let's say, 10 bonus points. If you can get this and have it turned into me at the beginning of the period. So you're going to give in 3 circles you have here with centers A, B, and C. And the radius, the radii of each circle, one has 7.5, one has 4.3, one has 30. And you're going to try to find the measure. So when we say solve the triangle, you're going to need to find the measure of these 3 angles. Okay, and it's not as simple as just saying that this is A, B, and C. Okay, think about that a little bit. And that is it for law of cosines. We're going to have, I believe, one more video for this chapter about area of oblique triangles, and that will cover it. So we've covered all 4 cases now, 2 with law of sines and last 2 today with law of cosines. We'll see you next time.